All right, so you know how we're surrounded by increasingly amazing tech like
Wow.
checks.
Absolutely.
I mean, our smartphones are practically mini computers, and AI is, well, it's getting smarter by the day.
Yeah, it's mind-blowing how fast things are changing.
But, underneath it all, there's this common thread, these tiny, mind-bogglingly complex things called semiconductors.
Semiconductors, the unsung heroes of the digital age.
Totally. And the demand for these things, well, let's just say it's skyrocketing.
There's no slowing down, that's for sure.
So today, we're going deep, really deep into this fascinating intersection, like how AI, the very technology these chips power, is virtually transforming how semiconductors are made.
It's like AI is coming full circle, shaping its own creation.
Yeah, exactly. It's like a feedback loop of innovation.
Yeah.
So we've been digging into some really cool material for this deep dive.
Oh, definitely some really insightful stuff.
Our main source is a blog post. It's from Orbit and Skyline, and it's titled, How AI is Transforming Semiconductor Process Optimization.
That's a great one. Really lays out the landscape well.
Yeah, and we've also pulled in some broader context from industry articles and all that, to give a more well-rounded view.
Yeah, I gotta see the big picture, right?
Absolutely. So the goal here is to really understand this impact of AI, in a clear way. We want to make sure everyone listening has those aha moments, but without like getting lost in the technical weeds.
It's all about striking that balance, making it accessible but still, insightful.
Exactly. So
Yeah.
before we jump into the AI part, I think it's important to appreciate just how crazy complex semiconductor manufacturing actually is.
Yeah, you really can't overstate that.
It's not just a factory. It's like a super clean, high-tech wonderland. They call them fabs, right?
Right, fabs, short for fabrication plants. And yeah, these places are, well, they're incredibly clean, like, classified clean rooms, class 10, 100, even 1,000.
Wow, so that means like even microscopic dust particles can mess things up.
Oh, absolutely. A single speck can ruin an entire batch of chips. That's why they have such stringent controls.
That's wild. And the Orbit and Skyline article, they really drive home just how many steps are involved. I mean, that they mention hundreds of procedures.
Hundreds, yeah, it's mind-boggling. And it takes forever, like almost a whole month to go from, the initial silicon wafer to a finished packaged chip.
A whole month. Wow. Can you walk us through some of those key steps?
Sure. It all starts with wafer preparation, getting that raw silicon ready. Then you have crystal growth, which that's where you actually form the pure semiconductor material.
So it's like growing a crystal from scratch.
In essence, yeah. And then comes lithography, which is it's essentially like printing, but on a microscopic scale. Imagine printing the entire circuitry of a computer onto something thinner than a human hair.
Whoa. And that's just, what, 3 steps in?
Yeah, we're just getting started. Then there's etching, which is that removes the unwanted material, leaving behind the intricate circuit patterns. And after that comes passivation, which is a protective layer to shield those delicate circuits.
Gotcha, like a shield.
Exactly. Then come the metallization, which is where we create those tiny electrical connections. And finally, after all that, the chips are packaged and tested rigorously to make sure they actually work.
So each one of these steps, it's like, it has to be absolutely perfect.
Right. The margin for error is incredibly small. If even one step goes wrong, it can result in faulty chips. And that means wasted time, resources, and a whole lot of money.
That's intense. No wonder they need those super clean rooms.
Absolutely. So yeah, any improvements in efficiency, any increase in accuracy, that's a huge deal in this industry.
And that's where AI comes in, right?
Right. Because the demand for semiconductors, it's not just staying steady, it's actually increasing, and it's demanding smaller, faster, more energy efficient chips.
And that's driven by everything, right? I mean,
Yeah.
our smartphones, the rise of AI itself, the Internet of Things, it seems like everything needs more powerful chips these days.
You got it. And it's not just about keeping up with demand. The cost of producing these advanced chips is also going up, way up. The designs are becoming more intricate. The technology is more complex, more expensive.
So it's a double whammy.
Exactly. They need to produce more chips, more complex chips at a lower cost and faster. And that's where AI starts to become incredibly valuable. It provides a way to streamline operations, anticipate problems before they happen, and optimize resource use in ways that were never possible before.
So AI is like stepping up to solve this huge challenge.
It's becoming essential, really. And what's fascinating is how AI's role has evolved. It went from being an application powered by semiconductors to actually shaping the way the entire industry operates.
So it's influencing everything from like the initial research and development to what even marketing and sales.
That's right. It's becoming integral to the entire ecosystem, a real driving force of innovation.
That's pretty incredible. But, we've talked about how complex and expensive this whole process is, and with all this pressure to optimize, what are some of the biggest challenges that semiconductor manufacturers are facing right now?
Well, the Orbit and Skyline blog and some of the other resources we've looked at, they highlight a few key areas. One of the biggest is around chip design, the technology itself, and the constant pressure to innovate.
Yeah, the chips themselves are just getting more and more complex, right?
Exactly. We're always pushing for smaller, more powerful devices, but that makes the manufacturing process more intricate and, as a result, much more expensive.
So it's like a constant battle against complexity.
Absolutely. And it's not just about today's designs. The pace of change in this industry is relentless. Manufacturers have to keep up with AI advancements, the Internet of Things, 5G, all these emerging technologies demand even more sophisticated chips.
So it's like a constant race to stay ahead.
You got it. And that requires a huge amount of ongoing investment in research and development. Plus, you need a highly skilled workforce that can actually keep up with all this rapid technological change. It's a constant learning curve.
So finding and training the right people that's a challenge too.
Huge challenge. And then there's the whole issue of supply chain logistics. Semiconductor production is a global operation, right? Different stages of manufacturing often take place in different countries.
Right, so you've got this intricate web of suppliers and transportation and all that.
Exactly. And as we saw with things like, the pandemic, this globalized system can be pretty fragile. Disruptions anywhere along the chain, whether it's sourcing materials or shipping components, can have a ripple effect throughout the entire industry.
And things like geopolitical tensions or even another global health crisis, that just adds to the uncertainty.
Absolutely. It makes it even more challenging to manage these complex interconnected networks. And then on top of all that, you have the challenge of the manufacturing process itself. We're talking about hundreds of intricate steps, remember?
Right. And each one has to be perfect.
Exactly. And that directly impacts what they call product yield, which is the percentage of usable chips that come out of the entire process.
So the more complex the chips get, the harder it is to get a high yield.
That's right. As chips get smaller and the features on them more intricate, the demand for precision and quality control becomes even more critical. You're basically working at the nanoscale, where even the tiniest imperfection can render a chip useless.
So it's like a constant balancing act between pushing the limits of technology and making sure you don't end up with a bunch of unusable chips.
Absolutely. And then you add in things like fluctuations in market demand, which can lead to either overproduction or underproduction, both of which can be costly. It's a very complex equation to manage.
And then on top of all that, there's the whole data challenge, right? I mean, with all the sensors and monitoring equipment in these fabs, they must generate an insane amount of data.
Oh, it's a data deluge. And that creates its own set of challenges. They need sophisticated systems to manage all that data, and they need powerful analytical tools to actually make sense of it all. The Orbit and Skyline piece really emphasizes how important this data is for things like monitoring equipment performance, ensuring consistency in the manufacturing process, and maintaining strict quality control standards.
So it's not just about collecting data, it's about actually using it effectively.
Exactly. It's about extracting valuable insights from that sea of data and then using those insights to optimize the entire manufacturing operation.
All right, so we've laid out the complexity, the challenges, the crazy level of precision involved in making these tiny chips that power our world. Now let's talk about how AI is actually starting to revolutionize all of this.
Yeah, let's get to the good stuff.
So where do we see AI having the biggest impact in this whole process?
AI is making its mark in a lot of areas, but I'd say one of the most powerful applications is in predictive analytics for process optimization.
And what does that mean exactly?
Well, remember all that data we were just talking about. AI algorithms can analyze that vast historical production data, looking for patterns and trends that humans might miss.
So it's like AI can see the forest through the trees.
Exactly. It can identify subtle correlations and use those to predict potential issues before they even happen. Things like inefficiencies in the process, defects that might arise, even potential yield losses.
So instead of just reacting to problems, manufacturers can now get ahead of them.
That's the power of predictive analytics. It allows for proactive optimization. They can adjust process parameters, make fine-tune changes, all to prevent problems from occurring in the first place.
That sounds like a huge advantage, especially in an industry where, like, every little detail matters.
Oh, absolutely. And it's not just about prediction. AI can also help with real-time process monitoring and control.
How would that work?
Well, you've got sensors all over the manufacturing equipment, right? Those sensors are constantly feeding data streams into an AI system. The AI can then analyze that data in real time, looking for even the slightest deviations from the ideal operating conditions.
So it's like having a super sensitive watchdog constantly monitoring the process.
That's a great way to put it. And the really cool part is the AI can often automatically correct those deviations, making tiny adjustments on the fly to keep everything running smoothly.
So it's like a self-correcting system.
Exactly. It prevents those little hiccups from turning into major problems down the line. And then you have AI-powered imaging and anomaly detection, which takes quality control to a whole new level.
I'm intrigued. Tell me more.
Well, think about those tiny features on a semiconductor chip. They're incredibly small, right?
Right.
Even with a microscope, it can be hard for humans to spot defects. But AI, especially in the field of computer vision, can analyze high-resolution images of those wafers with incredible precision. It can detect and classify even the tiniest flaws that would be invisible to the human eye.
So it's like having superhuman vision for quality control.
It's even better than that, because AI can analyze far more images, far more quickly, and without getting tired or making mistakes. It significantly improves both the speed and the accuracy of inspection.
So you're saying instead of having humans painstakingly inspect every wafer, they can now rely on AI to do it much faster and more reliably.
That's the idea. It significantly boosts efficiency and reduces the risk of human error. And it's not just about identifying defects. AI can also help to figure out what's causing those defects in the first place.
So it's like AI is playing detective.
Exactly. By analyzing all the data surrounding a defect, the AI can help pinpoint the root cause, whether it's a problem with the equipment, a variation in the materials, or some other factor. And that allows manufacturers to make more targeted and effective corrections to prevent those defects from happening again.
That's really impressive. So AI is like helping to improve quality control at every step.
Absolutely. And then there's predictive maintenance, which is another area where AI is having a huge impact.
Yeah, tell me about that.
Well, the manufacturing equipment in a fab is incredibly sophisticated and expensive. If a machine breaks down unexpectedly, it can bring the whole production line to a halt.
Yeah, that sounds like a nightmare scenario.
It is. But with AI, they can actually predict when those breakdowns are likely to occur and prevent them from happening. It works by using data from sensors attached to the equipment. The AI analyzes that data, looking for subtle patterns that indicate wear and tear.
So it's like AI can hear the machine starting to cough and sputter before it totally breaks down.
That's a great analogy. It's all about detecting those early warning signs. And by doing so, manufacturers can schedule maintenance during planned downtime, avoiding those costly and disruptive unplanned outages. The Orbit and Skyline article even mentions how companies like Intel and TSMC have seen significant reductions in downtime, like up to 20%, just by using AI for predictive maintenance.
Wow, 20%, that's huge.
It is. And it's not just about saving money on repairs. It also allows for more efficient production planning, potentially leading to faster product cycles and a quicker response to market demands.
So it's really about turning maintenance from a reactive process to a proactive one.
Exactly. It becomes a strategic advantage.
All right, so we've talked about how AI can improve efficiency, quality control, and even maintenance. But what about the cost of raw materials? Can AI help optimize that as well?
Absolutely. Semiconductor manufacturing uses a lot of expensive materials, things like high purity silicon, specialized gases, and various chemicals. AI can analyze production data to identify opportunities to minimize waste of these valuable resources.
So it's like making sure they're squeezing every drop of value out of those materials.
Exactly. And AI can also help streamline the entire supply chain, improving the accuracy of demand forecasting, optimizing inventory levels, and making the procurement process more efficient.
So it's like AI is bringing a level of intelligence to every aspect of the supply chain.
That's right. And that all ties back to the broader goal of cost efficiency, which is a huge concern for everyone in the semiconductor industry.
Right, because they're constantly under pressure to make those chips cheaper and cheaper.
Exactly. And that brings us to the critical concept of yield optimization. Remember, yield refers to the percentage of usable chips that come out of the manufacturing process.
Yeah, the higher the yield, the more profitable the operation.
Exactly. And AI can play a huge role in boosting yield. By analyzing all that data we've been talking about, the AI can identify the root causes of yield loss. It can pinpoint whether it's a problem with the equipment, the way wafers are handled, defect rates at various stages, or even something in the supply chain.
So it's like AI is acting as a yield detective, uncovering the hidden factors that are impacting production.
That's a great way to put it. And once those root causes are identified, manufacturers can implement targeted optimizations to address them and boost yield. The Orbit and Skyline blog even mentions how Samsung has seen yield improvements of 10 to 15% just by leveraging AI-based defect detection technologies.
Wow, that's a significant improvement.
It is. It shows the real-world impact AI is having. And it's not just on the factory floor. AI is also accelerating innovation in the research and development of new semiconductor technologies.
Really? Tell me more about that.
Well, as chips get smaller and more complex, the R&D process gets harder and more expensive. AI is helping to overcome those challenges by enabling faster prototyping and more accurate modeling in simulation.
So they can test out new ideas and explore new materials virtually without having to build expensive prototypes.
That's right. It's like having a virtual lab where they can experiment and iterate much more quickly and efficiently. The Orbit and Skyline blog even gives examples of how AI-driven simulations are speeding up the development of cutting-edge materials like graphene and carbon nanotubes.
So AI is helping to accelerate the pace of discovery in material science.
Absolutely. And as we continue pushing the limits of miniaturization, moving towards those incredibly small process nodes like below 3 nanometers, AI becomes even more crucial.
Those are the chips of the future, right?
They are. And making them requires incredible precision and control. AI is helping to achieve that by improving things like EUV lithography, which is a critical technology for creating those tiny features on the chips. It's also being used to optimize heat dissipation in those densely packed chips to ensure they operate reliably.
So it seems like AI is becoming indispensable at every stage of the semiconductor life cycle, from design to manufacturing to testing.
It really is. And our sources provide some great real-world examples of this in action, beyond the ones we've already discussed.
Yeah, the Orbit and Skyline piece highlights some really interesting implementations, doesn't it?
Definitely. Like Global Foundries, they've seen a 5 to 10% improvement in efficiency in their etching and deposition processes just by implementing AI-powered control systems. And Applied Materials, they've developed something called virtual metrology, which uses AI to predict the results of complex measurements, reducing measurement time by something like 30%.
Wow, that's a significant speed up.
It is. And the blog post also summarizes some of the specific AI applications that Intel is using, which are pretty impressive.
Yeah, Intel seems to be really embracing AI, right?
Oh, absolutely. They're using it for everything from real-time defect detection to advanced process control to automated wafer map analysis. They're even using AI to speed up root cause analysis and to detect outliers during final testing.
So it really seems like AI is moving from a theoretical concept to a practical reality in semiconductor manufacturing. It's delivering real results.
That's the key takeaway. While the full integration of AI is still in its early stages, it's already having a profound impact. And looking ahead, the possibilities are even more exciting. We're talking about the potential for fully autonomous fabs, factories that basically run themselves, constantly learning and optimizing without human intervention.
That sounds almost like science fiction.
It does, but given the rapid pace of progress, it might not be that far off. However, our sources also highlight some of the challenges and future directions that need to be addressed to fully realize this potential.
What are some of those key challenges?
Well, one of the biggest is data quality. AI models need a lot of high-quality data to train effectively, and in the complex world of semiconductor manufacturing, getting that data clean, standardized, and properly labeled can be a real challenge. Then there's the issue of integration. A lot of fabs have legacy systems that weren't designed to work with AI, so integrating these new technologies can be complex and costly. And finally, there's the issue of explainability.
Explainability, what does that mean?
It means being able to understand how the AI is making decisions. If engineers don't understand why an AI system is recommending a certain action, they might be hesitant to trust it.
Yeah, that makes sense. You want to know what's going on under the hood before you let the AI take the wheel.
Exactly. And looking further out, there's a lot of potential for integrating AI with other emerging technologies, things like quantum computing and edge AI. Quantum computing could accelerate the simulations used in material science, And edge AI could allow for even faster real-time insights and control on the factory floor. It's a really dynamic and exciting field.
So to sum up, it seems like AI is fundamentally transforming how semiconductors are designed, manufactured, and tested. It's helping to address those long-standing challenges of precision, efficiency, defect detection, yield improvement, and innovation.
Absolutely. And the rewards for embracing this technology are huge. We're talking about reduced costs, faster production times, and a competitive edge in this increasingly demanding global market.
So our final thought for you to consider today is this. Think about how these ongoing advancements in AI-driven semiconductor manufacturing will not only impact the devices we use every day, but also enable entirely new technological possibilities that we can barely even imagine right now. The future of medicine, transportation, communication, all these fields will be shaped by these increasingly sophisticated chips. And it's all thanks in part to the intelligent automation that's being integrated into their very creation.
It's a pretty amazing thought, isn't it?
It is. It really makes you appreciate the power of these tiny chips and the potential of AI to unlock even more incredible innovations in the years to come.
And that's why we do these deep dives, right? To explore those possibilities and get people excited about the future.
Absolutely. Thanks for joining us on this journey into the fascinating worlds of AI-powered semiconductor manufacturing. Until next time.
See you then.